here. We've got a standard that is a thinning standard. If you look at the end here, you can see that's relatively thin. Okay, turn it around, and you see at this end it's relatively thick comparatively. So the standard, as you can see, gets thinner as we travel this way across it. So I'm just going to turn this thing over and lay it flat like this. Okay, so now we don't see anything. If I turned it over, you would see that's what it's going to look like. So thick here, thin here. And I hooked up a low frequency probe. Let's get it all to go back. So I just unhook the probe, hook it back up here. Okay, now we're back. I'm going to push log so it knows what probe we're talking to. Go to main, frequency 1. It's already preset me at 3 kilohertz. That's good for now. I've got an angle of 0. Looks like it brought me back to the center. Yep. I just want to see where I'm going with this. Okay, so I've got a signal that comes off to the right like that, but I want to set it up so it goes back to the left. Okay, so I want it to look like my conductivity curve. Whoops. Just dropped you. If I was going to use my conductivity curve here, I lost my tripod, so you guys have to walk with me this week. If I wanted to do my conductivity curve, this would be what we would see. Okay? Looks like this, and then it comes down, 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 down. You know, simple stuff. What we want to do is look at this right here and make our way back this way. Okay? We want to look at that as it travels back to air. So that's kind of what we're going to do on a small scale this week, just with this thinning standard. Get you back over here. That's better. So I'm going to rotate my angle around, because if I go here and then go over here, okay, you can see the dot's way over here. Dot's right over here. Okay, there's my middle, and you can see I want to rotate all that. Okay, so I'm just turning this thing around. I want my lines to come in at an angle, which they are now. If I re-null, let's just take a look at what happens here. Okay, there we are. That's better. Now we're going up. I'm going to turn it a little more. That's probably good, I guess. Alright. But I want to take my gain, I want to take my whole screen and rotate it down like this. Or sorry, move it down. So the screen setup, I'm just going to take my vertical position down to about 10. Okay, and that's just going to put me right down here. If I null, that's where it takes me. Okay, null again. There's my liftoff line. Okay, another liftoff line. More, all the way up. Okay, if I wanted to connect all those lines, there they are. Okay, so any one of those, excuse me, any one of those impedance points, as you can see as I get closer to the edge down here, I've just about maxed out that probe, so there's really not a big difference. So if I would go to a lower frequency, you'd see those lines separate a lot more. Okay? And you see these lines just fill in here. Whoops, let's go back a little bit. Okay, these are all just thickness points now. As I walk across the screen, you can see the closer I get to the thin, the quicker those lines move. So all I'm doing is just looking at the end of that conductivity curve. Okay, that's just the thickness is all. So let's just take this, let's go back to main, let's go frequency 1, and let's drop this thing down to 1 kilohertz just to see how it changes everything. We're going to have to change our angle again. So let's null. Okay, we need to rotate. There we are. Whoops. Alright, so let's null again. Okay, whoops, I messed the probe up here. There we are, we're back. Okay, now we haven't even seen the whole end of the probe, so let's take our gain down. Let's go down to 50 here for fun. And what I did was lower the frequency, so I lowered or increased the standard depth of penetration. Okay, there's my little hook thing at the end. There we go. So 50 dB is too low. Let's go about 56 and null. Okay, there's the start of my edge effect. So I'm going to take my angle just for fun. Rotate it around a little bit. Re-null. There's my line coming back around again. So now, if I looked at all these thickness lines, now they're all smashed together. Okay? So, just looking at what that does with all my frequency. That's all I'm doing here. Okay? So let's take this frequency down even lower. This probe will go clear down to 300 hertz. So let's take it clear to the bottom, just for fun, just to see what happens here. Let's null. Okay, we're on the thick edge. So let's take our angle and rotate it around. There we are. Okay, we've smashed everything down all in one bit of information there. So what we figured out is the lower the frequency, at some point it's too low. Okay, so we need to calculate the best frequency. So when we do that, we've taken all that information and smashed it all together where we really can't see anything. So we've taken all that and just smashed it down to that. We still got the same information, it's just all in a tiny little spot. Whereas when we took the frequency and raised it up and we were around 3 kilohertz, we saw a nice big spread here for all those different thicknesses because we were pretty much set for that standard depth of penetration. So, just something to think about when you're testing your frequency and what that actually does with your conductivity curve or what that does with your thickness line. But this is a common application, testing for material thinning on the backside of a piece, and you can't see the top, maybe it's corroding from the backside. You just know that that thinning line is going to come up like this, so any point on there tells you, okay, well that material's gotten thinner, I've lost conductivity.